The sun is our nearest star. It provides us with warmth and light. We all know that the sun is important to life on Earth, but few of us have been given a good description of the sun and its composition.
Our sun is an average star, similar to millions of others in the universe, but it's a big energy machine. If you could capture the energy the sun produces in 1 second, that would supply the United States with enough energy for the next 13 billion years.
Where does the sun's power come from?
Good question. The basic energy source for the sun comes from nuclear fusion, and this is when mass particles combine and tons of energy are released. The core, or innermost part of the sun, is made of hydrogen. The sun is so dense, and its size is so large, that light released from the core takes about 100,000 years to make its way to the surface. If the sun were to stop producing energy today, it would take 100,000 years for significant effects to be felt at the Earth. Scientists think there is enough hydrogen on the sun to continue producing energy for another 7 billion years.
For many centuries, little was known about the sun. However, in the early 1600s, the Italian scientist Galileo used a telescope to take a closer look at the sun. He found dark spots that occasionally appeared and drifted across the sun. He also noticed that the dark spots on the sun's surface were constantly changing. These are called sunspots.
What are sunspots?
Let's find out. NASA Goddard's Dr. Eric Christian has some answers for us at the Naval Observatory. It's a blast.
Thanks, Dan. The sun is a fascinating place and a brilliant object to observe. We observe the sun through telescopes like this one here at the Naval Observatory in Washington, D.C. But satellites help us too. To get a better understanding of the sun, let's look at its different parts. The visible surface of the sun, that which we can actually see with the human eye, is called the photosphere. Temperatures here are around 6,000 degrees Celsius. The next two outer layers of the sun's atmosphere are called the chromosphere and the corona. The corona is actually hotter than the photosphere at temperatures of 1 to 2 million degrees Celsius. The corona is visible to the naked eye during solar eclipses. Remember the dark spots, or sunspots, that Galileo studied with his telescope? Well, sunspots are dark, cool areas of the sun's surface where charged particles are emitted. The sunspot only looks dark relative to the brightness of the rest of the sun, but it's still pretty hot, 4,000 degrees Celsius hot. The average sunspot is about the same diameter of the Earth. Sunspots generate some of the most violent storms in the solar system. When a sunspot erupts, we call this a solar flare. Solar flares are some of the biggest explosions in the solar system. When a solar flare occurs, gas heat of more than tens of thousands of degrees and energy surpassing billions of atomic bombs is hurled out from the sun. Another type of explosion is the CME, or coronal mass ejection. These explosions can reach speeds of millions of kilometers per hour and can reach the Earth in just 3 days. Both solar flares and CMEs can be very disruptive to human activity on Earth and in space as these storms, we call them solar storms, travel to the Earth.